Hello everyone, it's Prodie, and after about 4 days I decided to upload once again. However, this time there's been a bit of a problem, because I was asked, hey, what's interesting about what you're teaching? Now to me this is really annoying, because the reason it's a problem, I don't know if you've noticed, but it means that somebody isn't enjoying the content of my videos. I'd hate this to be the case, and what I advise them to do, and this is what I'd advise you to do as well, is just hang in there. This part of the series is kind of where you learn like how to make computers, how they all come together, all these different parts I've taught you about, like what it means to read and write in binary, what logic gates mean in an ALU. It all comes together here, and you get a better understanding. So it should be interesting. Actually, the write-up of this particular video it's not very important, and it might be a bit long and boring. So if you're watching my videos for the science, then a lot of this video you could probably skip. Not all of it, there are some important notes that you need to make that are inside this video, but you don't need to watch every single part of it if you're just watching it for the science. This section explains more the structure that computers follow. I'll explain the essential components of a CPU. So, essential components of a CPU. Why don't we start with the CPU then? CPU stands for Central Processing Unit. The Central Processing Unit lives at the core of all modern computers. It processes information that goes into the computer, and it can temporarily store that information for future use. The CPU consists of an ALU, some registers, and a large array of bistables, so basically memory. This is known as RAM. Together, these parts of a CPU can go through the lines of a program one by one, and they can carry out a sequence of instructions. For example, the first instruction might be take some user inputs. The second instruction could be save those inputs to some ALU registers. The third instruction might be perform the ALU add operation, add the two numbers that you saved. The fourth instruction could be save the ALU output, so whatever you get out from adding, say you've added 5 plus 3, you might get an 8 out. Save that output to RAM. The fifth instruction might be read from RAM, and then after that you can send that data that you've just read from RAM to the CPU output. So essentially you've taken two user inputs, saved them, added them, saved them again, and outputted them. This is a big cycle known as fetch and execute cycle. Basically you're fetching some information from memory or the user input, so ROM, then you save it somewhere, do something with it, and then save it back where it was. So you fetch it, you execute it, and you put it back. It's a whole cycle. Don't worry if you're not really getting this. Each part will be discussed in more detail a little bit later. Behind every part of a CPU lies the transistor. This amazing piece of kit dates back as far as 1947, where John Bardeen, Walter Brattain, and William Shockley invented the first transistor at the Bell Laboratories. In a possible future series on electronics, I might go over in depth the construction of transistors and how to arrange them in logical circuits, but for now an important fact is that they behave as tiny switches that can be turned on and off up to 10 billion times every second via a tiny change in voltage. Note this change varies between silicon and germanium transistors. If you make a silicon transistor, the change in voltage might require 0.6 volts, whereas in a germanium transistor you might need only 0.1 volt change. The modern type of CPU came from an architecture proposed by John von Neumann. Neumann described in 1945 how an effective computer should be constructed: a CPU that consists of a processing unit and a control unit, a memory unit, and an input-output system. The main difference between the Neumann machine and the computers that were built beforehand was that the programs were stored in a type of memory that was much easier to edit. Previously, editing the program would require the entire computer to be reconstructed and redesigned, which, of course, isn't really desirable. So, really, the Newman machine is mainly just an advantage for the programmer. Let's start this section of the series with basic designs for an arithmetic logic unit. Now this can apply to real life and in Minecraft. All that there is to an ALU is a collection of circuits that are arranged in a certain way to provide a reliable output based on the inputs. One of the inputs to an ALU should be a data input. Another should be the instruction, so what task the ALU is going to do. For example, the ALU might receive the input 0101, which is 5 in binary, for its data input, and it might also get 0010, which is 2 in binary, for its instruction. That instruction might mean add, subtract, NAND, or XOR, etc. One mistake I've made here is that I've said there's one input for the ALU for data and there's one input for the instruction. There can be more than one for data. You can have one input to the ALU for your data input, but that will make something called a single operanded instruction. I haven't really taught about operands or anything this complicated so far, so we're not going to worry about it. But generally you're going to want two inputs actually. Two data inputs into your ALU, and then there'll be one instruction input which will tell you what you're going to do with your two data inputs. Well, that's pretty much everything really. Well, it's not. We hardly talked about ALUs or their structure, but I kind of ran out of time considering how poorly written this episode was, and like I said, you only really want to get the essential parts of this video in. You don't need to learn about the whole history. I'll probably teach that again because it is quite important as you go on. As you begin to learn about the structure of advanced computers, you do need to know about Newman machines, and we'll talk about operanded instruction and all these other things I've mentioned. So, like I said, we didn't really go over the designs or anything like that, or the specific science. So I'm going to split the lesson into two parts. This first part is where we talked about the history and we went over things like Newman machines very briefly indeed. But in the second part, I'm going to talk about the logic of a binary adder, and I might just show you guys one in Minecraft. So, that's all. I hope you've enjoyed, but more importantly, I hope you've learned.